Suppose a plus b plus c equals to pi. We need to show that sine of 2a plus sine of 2b minus sine of 2c equals to 4 times the product of cosine of a, cosine of b, and sine of c. Okay, let us begin. Now this particular problem is a problem of conditional trig identity. The reason is, if we consider the trig identity sine squared theta plus cosine squared theta, this is going to be always true for any values of theta that we choose. However, for our case, it's given here that a plus b plus c equals to pi. So we only have to consider those specific values of a, b and c for which the sum equals to pi. Then this identity is going to be a true statement. Okay, so we're going to start our proof from the left hand side. So on the left hand side, we have sine of 2a. So that's added to sine of 2b minus sine of 2c. Okay, so here what we'll do, we're going to combine the first two trig functions, sine of 2n and sine of 2b, by taking help of the formula. So we know that sine of angle c added to sine of angle d, so that's given by 2 times sine of the angle a plus b over 2 multiplied to cosine of the angle a minus b over 2. So let's use that. So what will be sine 2a added to sine 2b? So here we can consider 2a to be corresponding to c and 2b to be corresponding with d. So we have 2 times sine of the angle, so 2a added to 2b, so that's simply going to be 2 times a plus b, and we have a division by 2. We will be left with only a plus b multiplied to cosine of a minus b minus we have sine of 2c. Okay, now this is going to be equals to 2 times sine of the angle a plus b multiplied to cosine of the angle a minus b minus. Now what is sine of 2c? Now there is a standard formula. So whenever we have sine of 2 theta, this can be expanded to get 2 times sine of theta times cosine of theta. So that means in our case, we're going to get 2 times sine of the angle c multiplied to cosine of the angle c. So this is going to be now equals to 2 times sine of angle. Now here we are going to use our given condition. That means a plus b plus c equals to pi. But in place of a plus b, what we can do, we can replace it with pi minus c multiplied to cosine of the angle a minus b minus 2 times sine of angle c times cosine of angle c. Now, what is sine pi minus c? There's a formula. So if we have sine of pi minus the angle theta, this is going to give back us sine theta. And now since pi minus theta lies in the second quadrant, so sine of this angle pi minus theta, that's always going to be a positive value. So we get positive sine theta. In other words, for our case, what we have sine of pi minus c. So this is going to get replaced with sine c. So we get 2 times sine of the angle c multiplied to cosine of a minus b minus 2 times sine of angle c multiplied to cosine of angle c. So this is going to be equals to, now what we can do, we can take 2 times sine of angle c as the common factor from each of the two terms, and that takes care of the sine c on the left hand side. So we have 2 times sine of c, this is going to get multiplied to cosine of the angle a minus b minus cosine of angle c. Okay. Furthermore, what we'll do, we're going to combine these two cosine functions. But before combining the cosine functions, we're going to make some changes to the second term, which is cosine of angle c. So here, the first term, let's keep it as it is. We have cosine of a minus b. But what we'll do, we're going to rewrite cosine of c as cosine of the angle pi minus a plus b. A plus b. So we are now going to get 2 times sine of angle c multiplied to cosine of the angle a minus b. Now what is cosine of pi minus a plus b? So here we're going to use the fact that whenever we have cosine of angle pi minus theta, this is going to be equals to negative cosine theta. Now we have a negative sign here. That's because pi minus t, as already mentioned, pi minus t lies in the second quadrant where the cosine function is negative. So what we can do, we can convert cosine of pi minus a plus b to positive cosine of the angle a plus b. Okay. Now what we'll do, we are going to combine these two cosine functions because we have sum of the cosine function. This is going to be combined by using the formula. If we have cosine of angle C added to cosine of angle D, that's going to be equals to 2 times cosine of angle C plus D over 2 multiplied to cosine of the angle C minus D over 2. Fine. So we're going to get 2 times sine of angle C multiplied to, so let's combine each of them. So we have the factor 2 multiplied to cosine of angle. So this is going to be C and this is going to be D. So let's take the sum. So a minus b added to a plus b, that gives us 2 times b, 2 times a, and we have division by 2, so that leaves us with cosine of angle a times cosine of, now we have to take the subtraction. So we have a minus b minus a plus b, so that's going to give us negative 2b, and with division by 2, so that's going to be negative b. We have 4 times sine of angle C times cosine of angle A. Now what is cosine of negative b? That's simply going to be cosine of b, because cosine is an even function. Now we know from the property of trigonometry, so whenever we cosine of negative theta, this corresponds to positive cosine theta. So that means we now have 4 times, so 4 times cosine of angle A multiplied to cosine of angle B times sine of angle C, and this is exactly the expression on the right hand side. So here we have shown that the left hand side equals to the right hand side, and in other words we can say, hence if we have sine of angle 2A added to sine of angle 2B minus sine of angle 2C, then this is going to be equals to 4 times cosine of angle A times cosine of angle B times sine of angle C for a condition, the condition being that the sum of the 3 angles of a triangle ABC, that is going to be equals to 180 degrees or pi radians, hence proof.